decisions about why we want to use those stock data as examples for us to study machine learning. So before we get into the details, let me go through my disclaimer. All examples and code presented in any of my YouTube videos are technical and illustrative in nature and do not represent any financial recommendations or investment advice. So the purpose of my videos are to show you how to actually understand deep learning, right? And stock data are just one of those kind of data that can be digested, analyzed, and by deep learning techniques, right? And sometimes you can use deep learning networks to make predictions. Sometimes those predictions can be accurate, but to a certain extent, to a certain level of probability. So at least at the current level, at the current stage of development, we cannot really reliably predict the stock market by using any kind of technical analysis. So at the end of the last video, we talked about several new tools that we are going to use for our deep learning studies. One kind of tools is related to processing the data, right? So stock data is kind of huge, and we need some really efficient data structure to hold the data, and then we really need some very efficient algorithms to process those data, right? And the tool that we're going to use is called Pandas. That's this particular software. That's which is a Python package. It's a Python package that's designed for fast, powerful, flexible, and easy to use data analysis and manipulation tool, right? And this particular package is very well designed for tabular data. So if your data can be represented as some kind of an Excel spreadsheet or any kind of spreadsheet, Pandas provides very efficient data structure for interacting with those data and analyzing those data. So we're going to use Pandas. We're going to use Pandas. It's a Python package. So if you are using any kind of a Python package management system like Anaconda, for example, if you are using Anaconda, right? It's actually very easy to install Anaconda. You can just go to their website, download a installation package, and then you can just follow the instructions to install Anaconda. And it comes with Anaconda. You have a bunch of packages that's pre-installed. That's going to be installed by default together with the Anaconda package manager, right? And if you go to the environments, there is a base or root environment, and among all those pre-installed packages, if you search Pandas, right, it's very likely that you are going to be able to see this particular package that's already installed by Anaconda. So if it is not installed, then it's gonna suppose I switch the package to all, right? And then if you search Pandas, you're going to be able to see this this item here, right? And if it's not pre-installed, then you can just click on this checkbox and ask Anaconda to install it for you. So it's not really a big trouble to install this Pandas software package. It's built on top of NumPy. NumPy, we have been using NumPy in all our previous videos, right? And Pandas is built on top of that. The basic difference is that NumPy is kind of a lower level because it doesn't actually have any kind of requirement on the data structure, but Pandas is actually built on top of that, and it's tailored to those tabular data. Right, we're going to look at some examples of using Pandas. It's very easy to use. It's a kind of a streamlined way of processing those data, those tabular data, right? And now this is a IDE that I'm using right now. It's an integrated development environment that's called VS Code. And in my previous videos, we have been using Spider. So we have been using Spider for all our code development so far, right? But Spider is kind of developed just for Python. So if you want to writing other kinds of languages, VS Code is actually a very good alternative to Spider. It also provides you this kind of integrated development environment, right? You can write code, test code, and debug code all in one interface. So if you have installed Anaconda successfully, then VS Code is installed by default, and you can launch it and use VS Code to write code. And VS Code is applicable not just for Python, but also for many other different languages. JavaScript, Java, C, C++, JavaScript, right? And pretty much all the languages that you can think of has a support in VS Code. So it allows you to use a variety of different languages, including Python, right? So we are going to be using this VS Code as our IDE. One of the things that you have to pay attention to before you actually write any code is to make sure that the Python interpreter is configured correctly. So how do you actually choose the Python configuration, right? The interpreter configuration is right here. It's right here. For now, my default is Python 3.8.5 64-bit base counter. This is actually the Python version or Python interpreter that's carried over by Anaconda. So Anaconda has its own Python interpreter that comes with it. So if you have successfully installed Anaconda, then you should have a Python interpreter that comes with Anaconda, right? But if you click on it, you will be able to see multiple versions of Python interpreters that has been installed on my laptop. So you can sort of see Python 2.7, right? That's some old ones. And you can sort of see Python 3.7, that's old ones carried. That was installed previously by other packages that's used on my laptop. But you want to pick the one that's that comes with the Anaconda installation, right? So I'm not going to make any changes to that. So I just press escape. Now we are actually in an environment to actually develop some codes. But what about the data? What about the data that we're going to use, right? What about the data? We're going to use some realistic stock data. It's not kind of a fake data. It's realistic stock data. So how do we actually get those stock data, right? How do we get those stock data? I'm going to show you the stock data that I downloaded from Yahoo Finance. It's tqqq.eod. EOD means it's the end of day data. So for every day you have a sequence of numbers. In the last video, I was talking about the 4 different prices, right, and also the trading volume for that particular day, right? So each row of this data, of this table, this huge table, is actually for one day. So the first column is going to be a timestamp. It's actually a Unix timestamp. It's a Unix seconds after a fixed reference time. That's January 1st. 1970 something, right? It's the number of seconds after that reference time, right? And then we have the prices. We have the prices for this particular instrument, TQQQ, right? But it's not just 4 prices. You got 5 prices. Why you have 5 prices, right? So this column is called the adjusted closing price, right? And then you have closing price, and then that's the opening price. That's the high price, the highest point, the highest price of the day, and then the lowest price of the day. And then the last column is actually the trading volume for that day, right? So you can sort of see the closing price is slightly different from the adjusted closing price, right? Why do you have this kind of difference? It's related to how you handle some of the stocks or some of the instruments actually has dividends, right? How do you actually average out that dividend payout throughout time, that kind of thing. And then sometimes some of the companies is going to split the stock 1 to 5, 1 to 6. Apple had a split for 1 to 5. Tesla had a split of 1 to 5 just recently, right? So if you want to account for those kind of events, right? You change the closing price a little bit, right? Throughout the entire history of the stock. Uh, but we are going to just use the closing price. We're not going to use the adjusted closing price, right? If you are interested in understanding what's the difference about adjusted, how do you compute adjusted price from the uh, original price, then please leave a comment and I will come up with a video to explain the differences, right? So we got 5 prices and then a trading volume, right? So looking at this particular format, it looks like this is a integer, right? This is an integer, and then we have 5 floating point numbers, right? We have to sort of get this entire data set into Python, and then do some analysis on it, right? Um, what I told you is that I downloaded this data from Yahoo Finance, right? So this is entirely free. You don't really have to pay any money to be able to access this kind of data, right? Yahoo Finance provides not just those EOD data. They also provide intraday data, also without any cost. And then if you try to understand the fundamentals of a particular company, they have fundamentals data, right? And it's also free of charge. So if you know how to write some kind of a web crawler, right, or download those web pages and analyzing those HTML files automatically, then you can write a script to automate this kind of download process, and you can get the data not just for one instrument, but pretty much for all the instruments that's carried by Yahoo Finance, right? This is another topic. It's not really difficult, but if you have no previous experience about how to do this kind of thing, there are also plenty of web resources that allows you to learn about it, right? To learn about it. So if you actually go to YouTube and just search Yahoo Finance download CSV historical, then it's gonna show you a bunch of YouTube videos, right? That teaches you how to actually do this kind of web scraping with Python, this kind of thing, right? And if you have a previous coding background, then it's very easy to pick up this kind of a technique. And if you have extra money, you can actually pay for it, right? If you have extra money, if you want to use some kind of a more professional, more reliable or robust data set, you have those kind of companies that providing this kind of data in real time. This is one of those companies called Quandl. I'm not sure my pronunciation is correct, but this is their website. Quandl. That's one of those companies that provides those kind of data. Suppose if you want to get to the end of day US stock prices, you just click on this link, right? And then it's going to tell you how to actually access those data, right? You can download them as a zip file to your local disk and then analyze them, right? Sometimes you don't want to consume disk space for storing those data, so if you click on usage, they actually provide a web API. So if you know what that is, it's actually quite convenient, right? You can write a web interface or web client, API client, to interact with their web API to retrieve the data directly into the memory of your Python script. You don't really have to sort of download it to your disk, right? And then if you want to use Python, then there's a Python client, web client, to interact with their RESTful API, right? And this Python package is entirely free. It's entirely free, but it's going to ask you to register for a free account. The packages are free, the clients are free, the software is free, but if you wanna subscribe to their data, you have to pay a small amount of money every month. That's a data subscription fee, right? For this particular website, it's around $40-50 per month, I think. And this is not the only company. There are lots of other companies. Another example is Tingo, right? Tingo is also another company that provides this kind of service, right? So So you have a choice. You have a choice. So I'm just gonna use those data that I downloaded or scrapped from Yahoo Finance to do some example work, right? So the data you downloaded or scrapped from Yahoo Finance is gonna look this way. It's gonna look this way, and we need to read those data from disk and then try to process them, right? Now let's look at some codes. Let's look at some codes, right? Let me just turn off this one. Let's before we actually dive into how to use deep neural networks to analyze those kind of data, let's just look at how do we read those data into Python by using Pandas, and then see if we can actually do some simple analysis by using Pandas, right? So if you want to create a new Python script, just click this button, and then we're gonna give it a name. Let's go to just read data.py, right? So now I'm presented with the editor window, right? So I can write my code now. So before I do anything, let me just do this. That's gonna create a Python cell, right? So if I want to debug things, I can just debug a piece of code. So every cell starts with this particular symbol. It's a Python comment symbol. That's the hash followed by 2 percentage signs, right? And we're gonna import pandas as PD, right? We're gonna import pandas into our script, right? Now let me define a function. Let's just do get data. And this function is going to take an input, which is actually the symbol of the instrument, right? It's supposed to be a string, right? So inside of this function, the first thing I'm going to do is to define the URL, the path, for example, right? Let me just call it URL. Suppose I want to change later on. I want to reuse this same function, but to access some data that's stored on the web instead of my local disk space. All right, and let me type into the absolute path of my volumes, right? And that's going to be the absolute path for the directory for storing all my EOD data, right? Not just for one symbol, but for lots of symbols, right? Thousands or tens of thousands of symbols. And then how do I actually read the data? How do we actually read this data, right? How do we actually read this data? We can use pandas. We can use pandas to read it by just using one function call. So I'm gonna store the output into a variable that's called a raw, and then I'm gonna use PD. And read CSV is a pandas function that allows me to read a specific file. So the file name is gonna be the URL plus symbol plus .eod. So all my EOD files are going to be stored in this particular format, right? tqqq.eod, right? TQQ is going to be the symbol name, right? And then I add this .eod to the end of the symbol to give it the absolute path, to give it the absolute file name, right? In principle, if you just do that, that's pretty much enough for you to actually read the data. You can get the data into this variable that's called raw, right? CSV actually means comma separated volume, right? Comma separated values, But if you look at this particular data, it doesn't have comma. So all the different values are actually separated by space, right? It's not really comma. So if you just run this code, it's gonna run, but the data is not gonna be separated into these kind of different columns. It's just gonna treat everything as just one column, right? So how do you actually do that, right? So by default, CSV is going to be comma separated. By default, it's going to use the comma as the separator. But here we are actually not using comma, right? There's no comma here. So we have to tell the function that we are not really using any separator. So SEP is one of those inputs, right? And then it has to be none, right? And that's not it. We are not done yet. Again, if you run this code, it's gonna run. But again, the output is not gonna be entirely correct. It's gonna be close to being correct, but it's not entirely correct because by default it's gonna treat the first row of the file as some kind of header row. So if you read an Excel spreadsheet, the first row, the top row, is the name of the columns, right? The name of the columns. So this might be the timestamp, the name timestamp, right? And then this is adjusted close, right? A string called adjusted close, and then closing price, right? Opening price, that kind of thing, right? So the header row is by default, this read CSV file is going to treat the first row as the header row. It's going to use the whatever content in the first row as the header row, right? But here we don't really have the header row here. So we have to tell this function that the header is actually none. Header equals to none, right? And then we have to tell, because the header is none, right? We have to tell this particular function what's actually the meaning of the different columns by assigning some names to the different columns, right? So how do we do that? We use another input that's called names equals to, right? It's going to be a list. It's going to be a Python list, right? And let's just give it some simplified names. T just representing the timestamp, right? That's a Unix timestamp. Adjusted close, ADJC. Close pricing, let's just use C. And then the next column is opening price. And then that's the highest price of the day. And then the last one is going to be the lowest price of the day. And then don't forget, we still have one last column, which is actually the trading volume for the day. Let's just call it V, right? This way we have assigned some names to the different columns, right? That's it. Pretty much that's everything for us to actually read this huge file. This huge, how many rows? It's probably got like more than 1,000 rows, right? Later on, once we have finished reading this particular file, we can look at the range of the data, right? How large the data actually is, right? And the Pandas, this is one of those very convenient functions provided by Pandas. And then another very useful thing for Pandas is to modify the data a little bit. For example, one of those very useful capabilities is to drop those not a number values. Those not a number values can sometimes bring trouble when you're actually processing them. For this particular example, we don't really have those not a number values, right? But if you are dealing with Excel spreadsheet that could have, for example, bad cells or empty cells, one of those very useful capabilities is called drop not a number, drop NA, right? If you call this .drop NA function to the output of this read CSV function, just by chaining them, then the output of the entire chain method is going to return a function that is going to return an output that doesn't have those not a number values, right? That's also a very convenient capability, right? And then once we have finished reading this, reading the file into this particular variable that's called raw, let's try to actually make some adjustment to it because this is a Unix timestamp. It's in seconds. It's in seconds that's referenced to a time that's kind of a very far distant in the past, right? We want to convert this Unix timestamp to a specific day of the month of the year, right? It's a lot easier to read month, a year, month, and day than reading this particular timestamp, right? This timestamp doesn't actually make any sense to us, but if we can convert it into year, month, day, this kind of format, that's going to be a lot easier for us to analyze it, to look at the data, right? So what we are going to do is to use another Pandas function, but the value we are going to modify is this T column in the raw table, right? Do you remember we have read the entire table into these different columns, right? The first column is T, right? So we want to modify it. We want to modify the T column from timestamp to a date time, right? PD dot datetime index. I'm going to convert this into a datetime index, right? PD, another PD function call, okay. To datetime and then the input to this inner function call is going to be raw t, right? So I'm going to send the t column of the raw data into this particular function called toDateTime, right? And then this toDateTime is going to take two inputs, not just the timestamp in seconds, but also another optional input that's called unit. And this unit is going to be second because I know that the timestamp that's downloaded from the Yahoo Finance is going to be in seconds. So if you just put SC here, then that's going to tell Pandas this is in seconds, right? And then we need to actually use a time zone. So time zone localize, it's going to be UTC, right? So basically that's method chaining again. So the output of this PD data datetime index has a method called TZ localize, time zone localize, and then we tell it it's UTC, right? And that's going to allow us to actually modify the T column, which from the timestamp to a specific date time, to a specific date, year, day, and year, month, and day, right? And then raw, we have to so by now this particular column is being treated as just one ordinary column in the entire table, right? But suppose we want to use this particular column as the index of the row, right? So by default, the index of the row is just going to be an integer, starting from 0, 1, 2, 3. That's an integer, right? But now we want to use this datetime as the index of the rows of the table, right? So we don't really have to use a integer as the index, right? So raw.set index, we're going to use t as the index, right? And this set index looks like it's calling on this raw data structure, right? But it's actually an object. This raw is actually a data frame object, right? Data frame is the most fundamental data structure of Pandas, right? And it's just like a table, right? And it's a container for storing the data, but it also has lots of methods that's defined to process those data. And the set index is one of those methods that you can call on a data frame object, right? We're going to set the T column as the index of the entire table. And once we have done with that, we can return what? Return what? We don't really want to return the entire table. At least for the simple examples that we're going to do at the beginning, we are not going to use all the different columns of the entire table, right? For example, we're not going to be using all the rest of the prices and also the trading volume. We're just going to use the closing cost, the closing price of this particular instrument. So all we have to do is to get the closing column of the raw table, and then wrap the whole thing inside of the data frame object, and then return it. And that's going to be our function for reading the data from the disk into Python, right? So if we want to sort of look at how to use this particular function, let's just do a very simple example before we finish, right? Suppose data, that's the definition of the function. Now let's use the function, right? Data is going to equal to get data. Let's just give it a TQQ. That's the symbol, right? That's the symbol. And then if we want to look at, some basic information about this data, don't forget this data is actually a data frame, right? It's a Pandas data frame, right? So it's got a functions or methods defined on it. The method that we're going to use is called info. It's going to print out some basic information about this particular table. That's called data, right? And now let's just run this particular cell. Can click on run cell to run this particular cell and see what's going to happen. Suppose we didn't make any mistakes, right? Okay, so looks like okay, it's still running. It's still running. Okay. Okay, looks like it has finished running now, right? So here it's the output. It's the output from this .info call, right? So it's telling you it's a data frame, right? It's got how many entries? It's got 1,554 entries. That's this many days, right? The starting date is 2015, January 2nd, 2015, right? And then the ending date is 2021, March 5th, right? So that's the, and then it's got a one column that's called a C. That's the closing cost, closing price, right? And it's not none. It's a float 64 float, 64-bit float, right? So by using this particular function, we can read the data that we scraped from Yahoo Finance into Python. So that's it for today's video. And in the next video, we're going to do some simple processing using Pandas, right? Thank you for watching.